In this video, I'm going to be showing you how to replace the telescope in the OPO-OPA system. I have one that's a lower magnification that I'm presently using, and I want to reduce the intensity as being seen at the 1 micron crystals. So I'll be at low energy with the Q switch delay set to 200 or 400, so that the energy of the 1 micron pump is around 180, 200 millijoules at the entrance iris. At these values, I can close down the entrance iris to give a nice small spot for realigning the system. Okay. Take out the old telescope. Put the new one in place. There we go. Now it looks like these are adjustable, and they are, but you shouldn't change it. They've been preset to create a collimated beam at the correct size from a collimated entrance beam. Okay, now I'll let the green through. Turn it up. And I'll notice that on the second iris here, leading into the OPO, you probably can't see it, but the green is off to the side. So I'll be readjusting the pointing using the first or the second external steering mirror. Turn that down a bit so I can see it. Okay. The next step will be to adjust the last green steering mirror inside of the OPO so that the green is centered in I3 at the exit aperture. You would adjust it with the controls that are available, but I'll check here right now. And it looks like this beam is not moved. It's still very much centered in I3. So the OPO itself is now aligned. We'll need to align the beam going to the OPA stage by using M3 and M4 to respectively center the beam in the 1 micron crystals and have the beam pointed in the same direction as the output from the OPO stage. To do this, I'll need to go to high energy, so turn the wave plates down, open up all the irises, turn the Q switch back to its previous setting, which for me was 260. Okay. Getting a fresh piece of burn paper here. And I'll observe the positioning of the 1 micron beam in the OPA crystals by taking burns at the beam dump. So turning up the wave plate to 45 degrees and then doing front and back burns. I find that the beam actually looks very well centered. I'm going to try that once again. Okay, that looks very nice. I can see from the front burn that the scattering on either side of the crystal light going around the crystal is pretty evenly centered. So I don't need to do any readjustment for M3, but I may need to readjust M4. So you would do this by looking at the green location coming from the oscillator in the far field, and then blocking the oscillator, turning up the energy of the 1 micron stage, and then looking for the green that's being produced in the crystals, and overlap with that with the pointing direction of the green coming from the oscillator. The final step will be to really look at the intensity of the beam that's going to the OPA stage to make sure that it's not too high for the crystals. And I use a special white paper in order to make that determination. The only place to be using this paper is between M3 and M4. I'm at full power right now, which is what I want to be testing. And what I don't want to see is this paper burn in the beam. You may be able to see some white fluorescence there. And I'm leaving the beam, paper stuck in the beam in one position. And after 10 seconds, I don't see any type of raising on the surface of the paper at all, and I can't feel anything with my thumb. If you start to feel raising, if it's right at 5 seconds that the paper starts to raise, that's about the highest intensity you want to do. The type of beam you don't want to have is where you just pass the card through the beam and it raises the paper on a single shot. That's too hot for the crystals, and the KTA crystals will damage at some point. So you would either need to reduce the energy coming into the system by turning down the Q switch delay, or changing out the telescope just as we have done today. So.